Ladies and gentlemen, I'd like to welcome you to the joint House and Senate Science and Technology Committee hearing. Have with me Senator Loudermilk, the chair of the Senate S&T Committee, and again, State Representative Ed Setzer with House Science and Technology. It's a pleasure having our first informational hearing today. I'm really excited about our presenters. We have both presenters from the State Department of Economic Development and from industry, and it's a subject matter that we I think have interest outside of just this committee. As many folks know, there's been various plasma arc technologies implemented across a number of marketplaces over the last couple decades, but the submerged plasma arc technology that's going to be discussed today, a little different. I'll let the representatives talk to you about those distinctions, but our interest is not just to provide a more high profile for some great research that's going on in the state of Georgia, but also investigate some potential legislative actions that could be meaningful to really bring it to market. I'm aware that there's a distinction between invention and innovation. Invention is coming up with new ideas. Innovation is bringing them to market in a successful way. And the Science and Technology Committee is interested in seeing where we as legislators can work in concert with the private marketplace and our executive branch agencies in allowing innovators to be successful in Georgia. So that having been said, Chairman Loudermilk, anything you'd like to share?
Well, thank you, Mr. Chairman, and I've had the opportunity to meet with these folks before, so I'm very excited about this technology and what they're bringing, and I think it's bringing new ideas to industry that I think will benefit customers as well as the state, as well as the industry itself. Being in the technology field, I'm excited about all new technologies, especially when you can take something that is considered a disposal waste by some and turn it into something that will create jobs and create a new market. So I'm looking forward to it, Mr. Chairman. Thank you.
Thank you. With no further ado, I'd like to recognize the Director for the Center for Innovation for Energy Technologies with the Department of Economic Development, Kostas. Take it away.
Yes, good afternoon. My name is Kostas Simoglu. I'm with the Center of Innovation for Energy. We're a division of the Georgia Department of Economic Development. For those of you who don't know us very well, the Centers of Innovation were created to support our strategic industries. And basically what we do, we provide expertise and connections to the Georgia strategic industries to grow fast and compete globally. I work for the Center of Innovation for Energy. So a little bit back before why the Centers of Innovation? Because we believe the future of innovation technology is based on the collaboration between the private industry, government, and the universities. So at the Center of Innovation for Energy, we looked at the current model. We tried to predict the future energy model, and then try to determine what the economic development opportunities will be. While we're doing this, we came across these type of predictions. Then we said maybe we need to slow down a little bit and take advantage of what we've learned from the other strategic industries in the past. So my background is the technology industry, and remember where we had the software industry, we had the hardware industry, and we had the telecom industry. Each one had its vertical, and nobody was talking to anybody. But once everything started to converge in the 90s, we had this tremendous amount of innovation and wealth creation. And so we believe that the same thing will happen again with the energy industry. So we look at the current status of the energy industry for the state of Georgia. The three verticals. One is the petroleum products, the second is coal, and the third is natural gas. We have none of these here in the state of Georgia, so we have to purchase it. And on an annual basis, we spend somewhere around $30 to $33 billion. It changes every year, whether it depends how many miles we drive or if it's warm or cold. And then we compare this to the state budget. So it's a tremendous amount of money that goes out of the state every year. So the idea is that if we look at it, the whole energy industry from the ecosystem perspective, and the energy generation, energy transmission and distribution, energy storage, and the energy use, we will identify that there are a lot of industries that can be created, a lot of R&D jobs, a lot of manufacturing jobs, and a lot of service jobs, and these are all local jobs. and regional jobs. And in the center of the circle, that's where the role of the government. Make sure we have the right workforce, make sure we have the right legislative framework, and then the right type of applied research and the funding. We have all these ingredients. We're among the best, or if not the best, in workforce development. We have now developed the model how to fund applied research, and we have the right legislative framework. We have a business-friendly government, so it makes everything very easy. So, but if we look at the energy generation vertical by itself, what are the advantages of the state of Georgia or the Southeast in general? We have solar, we have biomass, we have wind and also waste energy. In the solar industry, we have two companies here in Georgia which manufacture, they have R&D and manufacturing facilities that make solar cells and solar panels, Saniva and MagnaGas. And we were missing one component, was the inverters. And we recruited a company from Switzerland to be, they were the missing link basically in our solar industry. And now the industry is growing by itself, and it's going to grow in the future. The biomass. We focused a lot on biomass and biofuels in the past few years. The pellet industry has grown, and we're one breakthrough away from converting biomass to biofuels. On the wind energy, we have about 15 to 20 companies that manufacture parts and lubricants that supply the wind energy. And now on the waste, on the waste energy industry, there are a lot of opportunities there, but some of the technologies are not there yet. In Georgia, we have a lot of solid waste, we have a lot of liquid waste, agricultural waste, and industrial waste. So we look for technologies, what technologies out there are available to convert that waste into energy. We're also working very closely with the Department of Natural Resources to map the entire waste supply chain and use that for economic development purposes. So in the waste energy area, we look at the liquid waste energy, what's available out there. The only thing that we found is that some type of technologies that they process manure and they create methane, and that's about it. The only technology that we found that was the most promising and the more advanced than anything was the one of MagnaGas, which they will describe to you shortly. So we contacted them, and we've been in discussion since last November, and we are starting an R&D project at the UGA Tifton campus. It's going to start in about a month. Everything is in place, and the second phase, in the second phase, we're going to involve Georgia Tech. All this fits within the mission of our department, which is grow, expand, and recruit. So and we have a dream and a mission to be known for something here in the Southeast. We have so many industries, but there is nothing that they can pinpoint and say this is what is the Southeast for. The same thing as when you talk about Silicon Valley, you know what they are. When you talk about Wall Street, you know what they are. We have all the ingredients to become the Green Tech Corridor, or whatever name else they're going to give us if we promote them and the energy technology industry. Thank you. Any questions for me, or
we can ask questions as we go. It really is the preference of the presenters. If you'd rather get through the presentation, if in fact, Costas, if you'd stand close by, we might have some questions that pop up later that are relevant to you. Chair, I'd like to recognize Mr. Romano Santilli, CEO of MagnaGas. Santilli, thank you.
Thank you. And thanks for the introduction, Costas. We at MagnaGas, we think of it very simply. We basically take liquid waste and we convert it into energy. We convert it into a gas, or we convert it into an effluent, which has a value, and gas. If you look at most of the technologies out there that are waste to energies are mostly hard or solid. Thank you, John. Solid waste to energy. We're the only technology that we're aware of that is liquid waste to energy. Okay. Just some of the company highlights. It is patented. We'll go into a lot of details about the different feedstocks and everything else, so I'm not going to spend a lot of time on this right now. It was founded in 2007, but if you skip on to the world-class technology in the middle there, my father, Dr. Ruggiero Maria Santilli, he spent a lot of time at the universities of BU, Harvard, MIT, and he actually received the grant from the Carter administration to seed this technology. So it's taken around 30 years, and it hasn't been a direct path, as these things never are, but here we are today thanks to the Carter administration grant. We have multiple streams of revenue, which I'll talk about, and our growth is basically linked to retail sales of our gas and partnership with large organizations to sell our other products, such as the sterilized manures, gas, and heat. I like to show this slide here, number 3, so that people realize we're not hoping that this is going to work. We know it works. And we have some of the largest organizations in America and in the world who are our customers already. On the left-hand side, you'll see what I call it the lowest hanging fruit on the tree. Packaged gas to the metal and the metal recycling industry. One Steel, Ferris, OmniSource. I think all 3 of them are in the top 10. Ferris, we're taking their liquid waste and converting it into gas. We're actually shipping a new batch of gas today, and we're testing the liquids. I believe last week they were received, and this week OmniSource is a customer of the gas, but we're exploring taking their liquid waste as well. General Motors is a very specific relationship that we'll talk about. The Navy, I just want to make it clear, we're testing with the Navy. It has been a long process. The main gas for the industrial gas industry related to cutting is acetylene. Acetylene is dangerous to produce, dangerous to store, dangerous to use, carcinogenic, but it cuts well. Before magnetic gas, there was nothing else that really cut like acetylene. And on the lower left-hand corner there, the fire departments, we're testing with 2 fire departments in 2 different states. One of them is quite famous. I'll talk about that as well a little later. Our footprint, we consider ourselves to be light global. We do have units, I don't want to say around the world, but we do have units, 4 operating in the US, 2 in Florida, 2 in Michigan. We've got units in Beijing, and we've got 2 units in Italy. The other pins, I'm not going to get into too many details about them, but it's representatives, it's authorized distributors, and it's the headquarters. We have 2 main poles of headquarters. One is in Florida, Tarpon Springs, which is for the Americas, and then over there in Brussels, which I just moved from 6 months ago, is the European headquarters. The process is very simple. We basically, let me see if I can use this here. Can anybody see that pointer? We basically take our liquids, force them into our gasifiers, and there the liquid is subjected to the 10,000 degree temperature of the arc. The gas bubbles up, is collected, and either there is a carbon sludge at the bottom, which is minimal, or you have a sterilized effluent, which is minimal. So it's just a gasifier. My father would slap me, but it is just a gasifier. It is a submerged liquid gasifier. This is really important to understand. There's two operating modes. Gasification mode is used to totally eliminate a liquid. Oily liquids, liquids from the automotive industry, cutting liquids, hospital liquids, anything which you would never want to see spilling into or being dispersed into the environment. On the right-hand side is sterilization mode. Sterilization mode is meant to sterilize only and maintain the volume and the biological value or the nutritional value of that liquid. So here on gasification mode, we'll take 1,000 gallons of PCB-laced oil for GM. We'll turn it into 30,000 cubic feet of gas, and it's all gone. The liquid's all gone, except for this carbon sludge. On sterilization mode, we will take human or cow manures, and we'll sterilize it so there's no biological activity. Parasites, viruses, bacteria, everything's dead. But we maintain the nutritional value of that liquid. Okay? So with sterilization mode, if you start with 100 million gallons, you end up with 100 million gallons of sterilized sewage. And that can be used for fertilization. So either way, we're taking liquid waste and we're transforming it into something which is more usable. Revenue streams, first of all, is the gas. The gas is very versatile. In our shop, we run forklifts. We have a car. We cut metal. We've had a Magna gas barbecue. I mean, it does everything that natural gas and propane will do, and you could arguably say it's even better. Sterilized liquids on the upper right quadrant. Sewage to irrigation, manures to fertilizer, and hospital wastes. I say hospital waste here because if you have hospital sewage, which is a very high volume of water, in it you're going to have discharged hormones, drugs, and everything else that will end up in your groundwater, and that will decompose much slower than other things. So Holland has problems with groundwater issues of drugs. We can destroy all that. We can turn it into irrigation water. Liquid elimination, lower left-hand corner, the fogs, fats, oils, greases. As long as it's pumpable, we can gasify it. And some liquids are much more productive than other liquids. But generally speaking, if it has an oil base to it, we turn it into just a great gas. Our vision actually is that today you will drive up to your municipal dump, you'll dump off your trash, and somebody's going to store it. In the future, you could have a liquid waste treatment facility where it's kept separately or it's mixed to make it more suitable for gasification. So we see this as a technology that complements the existing waste energy technologies out there, because typically when you have a solid waste, you're going to have a liquid effluent that you need to take care of as well. And then on the right-hand corner there, lower right-hand corner, electricity generation. You can just burn it and create electricity. Or what we think is a more valuable use is that you can co-combust it in a coal fire plant. I won't go back to that map of the world, but Magna Gas Australia, they have focused almost purely on co-combustion and making sure that they're testing that they can turn animal fats into gas to run the rendering plants. They have a little movie, and it's quite long, but basically what it shows is they show you a little coal furnace burning coal, and they have a temperature sensor, and of course you have that white sooty smoke coming out. When you inject Magna gas into the flue, the smoke becomes totally clear, and all there is the heat distortion. It promptly melted the temperature sensor, but they were getting very, very high flame temperatures in there. Am I saying that it's 1-to-1, 5-to-1? I don't know. But we do know that co-combustion with a higher flame temperature leads to better and more efficient burns of existing hydrocarbons. Advantages: we don't burn this. There's no smoke. It's not done with the air. It's very low noise. And if you're in the industry, you would just say it's a syngas. H2CO, it's a syngas. But unlike other syngas processes, ours, straight out of the unit, is ready to be burned. There's nothing that needs to be scrubbed, nothing that needs to be done. If you want to compress it, you just need to dry it because of the presence of CO. But that's it. So the advantages are several. And the most important advantage that we see, and our General Motors sees as well, 2 weeks ago I was sitting across from the table from the scientific fellow of General Motors who's in charge of their renewable energy. And she said, the old General Motors was very risk averse, and that's changed. We now know that we have to pick the technologies we want to bet on, and it's possible that magnetic gas is one of those technologies. I think it is, she said. I said, why? It's because you're the only technology that is a waste to energy that doesn't require dewatering. I mean, dewatering, for every ton of water, it's an enormous amount of energy to dewater the solid wastes. We need the water. As long as it's pumpable, we can turn it into a gas. The units are versatile. I'll show you some pictures later. And we actually have a new remote diagnostic that you can operate it remotely. You can check how it's going. You can see how much gas it's produced. It's sizable, stackable, and it's mobile. We actually have 2 trucks. That one truck has the gasification vessel, and the other truck has the cooling towers, the compression station, and as long as you have the electricity, heat exchangers, yeah. As long as you have the electricity, you can connect and disconnect in a day and move it somewhere else. Financial, we try and target a payback of 2 years for whatever market we're going into. That's why we're focusing on certain markets where we know the margins are there. A 300 kilowatt unit, which produces 18 million cubic feet of gas in a year, goes for $1.7 million. If you can sell it at the same prices that you sell acetylene, and we're targeting a bit lower, you can make that back very quickly. It has I believe it has a shorter payback than 2 years. Future growth. Today, it costs around 2 cents a cubic foot to produce our gas. I'm sorry. Once we get feedstock for free, which we're going to talk about, meaning waste feedstock, fogs, it's 2 cents a cubic foot. If we find a feedstock where the magnetic gas is paid for disposal, or we can sell on the fertilizer, your cost goes to 1 cent or 0 cents or negative. That means that the hydrogen you're getting out is effectively free, which is exciting. Related to that, we would like to do fuel cell testing. And I'm sorry, this should read 2013. One of the gentlemen from General Motors who was in the last meeting we had is from the fuel cell and alternative fuel testing division. We also want to look at smaller recyclers. Right now, a 300 kilowatt unit that can produce 18 million cubic feet of gas it sounds big, but it's still quite small, but we want to make it even smaller. Our 200 kilowatt unit, which is in Italy, will sterilize all the sludge from a 20,000 person village in 1 hour. So the throughput is quite large. Regarding general initiatives, I say this, the team is sick of hearing me say this, but we're a technology company. All we want is access to markets. We need to continue to leverage our relationships with the Navy, fire departments, General Motors. Actually, ever seen the movie Dream Machine, the television show Dream Machines, where they construct those crazy cars for those celebrities? It's on the FX channel. They're now using our gas. Things like that build relationships with people, and that's where we have to continue to leverage. Media, as long as it's targeted, we want to have a media campaign, and we want to have strategic partners in every sector: gas, waste to energy, electricity, Those are basically our general growth drivers. These are some of our units. Upper left, that unit is actually operating. That's the one that runs our gas in Tarpon Springs. This is one of our trailers. This is the actual unit here. Heat exchangers over there. And this cabin is for the operator. This unit looks small, but it's actually huge. I could actually get into the unit with my body and I wouldn't touch the sides at all. Right into that section there. This is a little unit in Italy. That's a mobile platform used purely for testing. And this is our unit, which is in China. This is a 300 kilowatt. This is a 300 kilowatt. This is a 50 or 100 kilowatt. This is up to a 500 kilowatt. And this is a test unit that the Chinese made, so I suspect it's identical to our 300 kilowatt unit. Okay. Sterilized product. Again, 2 operating modes. Gasification mode totally eliminates the liquid waste. Sterilization mode keeps the liquid waste and just sterilizes. The key thing is typically, if you're in the industry, and this hasn't been announced yet to anybody, you need a flocculant and a coagulant to be able to get that manure out of the sewage. Typically, that's the most cost-effective way. Italy have concluded a 9-month study where they showed that sewage through our unit at the right speed, too slow, you don't sterilize, too fast, and you're chopping up the molecules into smaller and smaller pieces, that if you get the right sweet spot, then you can dewater it partially in a centrifuge, and the water coming off the centrifuge meets European regulations to be used as an irrigation water. That, for us, is a big milestone. The final test, which they're concluding on shortly, is to dewater the mud or the sludge from the 85 to 75 down to 65. And then they feel they have a market not just for the water for irrigation, but also for the fertilization. Now, one important point is that if you have heavy metals, if you have anything which is inorganic going in sterilization mode, you're going to have it going out. So we just sterilize in sterilization mode, nothing else. And we try not to get involved in local requirements on filtration because every municipality has their different requirements, whether it's the U.S. or Switzerland or whatever. Everybody has different requirements. So we let local people do the filtration. This is also suitable for medical waste, which is continuing to be a problem. Quickly, I'll run through these. Transport fuel, that is a Magna gas car. It's a bi-fuel Cavalier. All we had to do was change the bottle. That's it. And it was turn the key, and it's running on Magna gas. The forklift trucks, the hydrogen market, we actually have a PSA station, pressure swing absorption station, that we're using to separate the hydrogen. And excuse me, we haven't done it yet, but we are going to test the hydrogen in fuel cells, and we suspect that it's going to be very effective. Metalworking, this is the lowest hanging fruit on the tree for us. We'd rather the gas, we sell it to some of the biggest and smallest companies around the U.S. Heating and cooking, and then co-combustion, which is what we discussed. This is an interesting slide. The middle column is the test results of a Honda Accord. This was probably 7 years ago now, running without a catalytic converter, and these are the emissions. On the right are the EPA requirements. So running on Magna gas, a car complies with the EPA requirements without a catalytic converter. I believe that natural gas does not, because of the carbon monoxide. It just shows you that at a high flame temperature, you're going to have a very efficient combustion. This, hopefully you can refer to your printed documents for this, and I apologize. These are 4 printouts from a kind of a DMV testing station showing the same car, it was a Mercedes, running on natural gas on the left twice and running on magnet gas twice on the right. Now, if you look carefully, what's interesting is the changes in CO, CO2, and hydrocarbon. You go from between 170 and 300 down to 0 parts per million, which is pretty unbelievable. Was this a scientific test? No. Was it independently verified? No. But this is what we do every day. Whenever somebody comes to tour our facility, the end of the test is, as Costas has seen, is we run our gas in a little engine, we test it in an analyzer, we tear it off, and we hand it to the person. And that's one of the most amazing things, because they can always physically refer to that as saying, wow, it really is different. Magnet gas really is different. Right, Costas? So, metalworking, we don't have to spend a lot of time on this. This actually was, this piece of metal here was cut in Westfalen, Germany, one of the largest gas companies in Germany. It has a lot of advantages. And frankly, acetylene should be banned. It is dangerous to produce, dangerous to use, carcinogenic, and we'll talk about the Navy. They're phasing it out totally. Magnet gas coming from liquid waste is a better, cleaner, safer, more efficient cut, more efficient gas. So, Matheson, one of the big boys in the gas industry, we signed a contract with them recently, actually in Q1, where the problems we were having in the market and the gas industry is basically the bottled gas industry is a form of a duopoly. There's some big boys. Getting in is very difficult. Unless you have all the gases, most people don't want to deal with you. So Matheson is a game changer for us because it lets us go to customers who love our gas but want to buy all their stuff from us and couldn't in the past. And if you look down here, LVI, one of the largest demolition companies in America, there's no other gas on the planet that can cut some of these very large castings. We have found that only magnet gas can. I'm not going to spend too much time on these 2 items. This is also related to the metal cutting industry. We've got some large players such as RJ Torching. We have people who are looking to secure exclusivity in certain markets and pay in advance, which we kindly accept. This is where it gets interesting. The 2-state fire and rescue, they have 2 or 3 cutting systems on their trucks. And as you can imagine, with technology, the risk of radiation threats, the biological warfare threats, they're getting more and more kit on these trucks. They're running out of space. And if I was a fireman and I was running into a burning building to save a family, the last thing I'd want on my back was a bottle of acetylene. Because you fall down that set of stairs, you stand back up and go into that building, you're like a running bomb, just waiting to go off. Literally, that's how dangerous it is. When you take acetylene and it's diluted in acetone. When there's a physical jar or a shift in temperature, which is dramatic, it can disassociate and just explode. So all that happens to the firemen. So we demoed the gas with them several times. They love our gas. We're physically on some of the fire and rescue trucks in these 2 different states. General Motors we talked about. Phase 1 was, show me your gas, I'll cut with it. If I like it, great. We passed that now. They like our gas. Phase 2 is we're testing liquid wastes, but we know we know that the oils they showed us will create a gas. That's not a problem. We are eager to go to phase 3, which is the transport applications and the hydrogen separation. We would like it tomorrow. They're not in a big hurry. They want us to obviously go through phase 2 first. But if this works, General Motors will have access to effectively free or low-cost hydrogen, which is a great thing. The Navy are trying to eliminate acetylene. Acetylene is carcinogenic, as I said several times, and the cutters who are building ships and cutting down ships, they find a high incidence of a specific type of lung cancer which is related to acetylene. So they started a program to find an alternative gas. Acetylene isn't even considered. We started with seven gases, and now it's down to 2. Magnetic gas is in the final running. And because our flame temperature is so much higher than the competitive gases, that's the enterprise there. In, I think, 3 years, it's coming in to be cut. And somewhere on the West Coast. It's like a 20-year project. Every time you cut with propane or the acetylene, you're burning all of the area around where you're cutting. So if you're working in a shop, you're using new steel, it doesn't really matter. If you're working with a ship that has 20 layers of paint, some of it lead paint, God knows what, you can't tent them, it's too big. So we're confident that in the final stage, it's between ourselves and propane. Propane heats up 3 times the swath that magnetic gas does when it cuts. So we're pretty confident that we're going to get this business, but until you get it, we're not going to count the chicken. Latin American market. Mexico is very strict in certain laws, particularly around the burning or elimination of oil wastes. The electric company in Mexico called CFE has troughs of oil waste laced with PCBs as far as the eye can see, and they have no technology to get rid of it. They can't burn it. So with magnetic gas, we're going to chip away at that. They're going to probably need at least 6 to 10 units to pass the threshold of the recycling, the volume of oil that you can recycle. But in Mexico, they get 4 kilowatts of power for every 1 kilowatt of power they can put back on the grid. At that point, they could just stop there. There's a feedstock as far as the eye can see. This is the financials. We don't like to print these out, so it's not going to be in your printout, I believe. Please confirm that it's not in your printout. I'm only joking. I don't know if you can see it, but at $20 a cylinder, operating around 85% capacity, you'll make roughly $1.8 million a year in revenue. And if the fogs is, assuming you don't get paid for it, it's just for free, you're taking it off somebody's hands, you're going to make a gross margin of about 65%. So if we skip to the answer, that's around 2 cents a cubic foot. With that, you can package it up. You can use it.
Could you be a little bit more specific? Kind of walk us through again.
Yes.
The economics there.
Sure. This business model here is purely based on using fogs, which we're going to assume for this model are free, as opposed to paying for or.
So free feedstock coming into your systems.
Yeah. So
okay.
Wasted fats, oils, and greases,
okay,
which are pumpable. When we gasify them.
No. But before we go there.
Sorry.
Is there normally a disposal fee that someone pays? Is there a tipping fee they get given back for? What's the economics of waste disposal without on the marketplace today in Georgia?
Well, I would love to tell you that I can speak to that in details, but Florida won't let us bring any liquid waste on our facility.
Okay.
So, but I can tell you what General Motors does. They have like 300 different wastes. Mm-hmm. Some are hazardous, some are non-haz. Some they get paid to dispose of. For example, they'll buy certain relatively clean cutting oils from them. Other liquid wastes are mixed or commingled with waters and other things, and they have to pay to get rid of them.
Okay. So in the big scheme of things, it's about somewhere. It's about an equal proposition.
Well, yeah. We in this industry, for example, the biomass industry, in the past, people used to count as a revenue all these solid biomass disposals, and all of a sudden, once the industry took off, there were other people competing for that same solid waste, and they ended up paying for it. So my understanding and what we do is we assume that it's a net cost from the start.
Okay. So given that, I'm sorry I interrupted you.
No, it's okay.
Okay.
So given that, the answer is over here, the 2 cents a cubic foot. Propane is, for the best users, I'm not saying Home Depot, but from the best users is 6 cents a cubic foot. 6 months ago, it used to be 10 cents a cubic foot or more. At 2 cents a cubic foot, with no R&D on the unit for efficiencies, there's a lot of scope there to be able to produce enough gas for the entire industrial gas community in Georgia for sure and elsewhere. I mean, one unit will make 18 million cubic feet of gas. Now, I made a little calculation on the flight over here. If Magna Gas was paid $1 per gallon to dispose, which isn't a crazy number, General Motors do pay that on some of it, and Mexico, it was a high multiple of that to get rid of the PCB-laced oil, that number goes down to 1 cent a cubic foot. So we believe that 1 cent a cubic foot, it's a very strong value proposition to cut metal, forklifts, cars. You can inject it into natural gas filling station to get a higher flame temperature, to get a lower emission. I mean, there's lots of opportunities there.
So what I'm hearing from you is that your constraint is people who are willing to give you waste material, is what you're saying?
Well, it's finding a facility that will allow us to bring waste on site.
Okay.
But we think that with General Motors and other large players such as Ferris, we'll have access to that. If we take a tote, which is about yay high, of oil from General Motors, it will cost us around $300 to ship on a truck down to Tarpon Springs. That's a fourth cheaper than what we're paying now for new ethylene glycol, which is our current feedstock. So, yes.
The business model is not making and selling these byproducts, it's making the machines and selling to the people who are going to make it.
Well, we are still finding out that some markets, excuse me, some markets don't want to invest $1.7 million. They would rather just say, like RJ Torching said, I don't want to buy a unit. I'll give you this little corner of my lot. You put your unit there, you operate it, and just sell me the gas. So that's what we're doing. Other places like Mexico see that this, for the Mexican market, is a huge opportunity financially and also for the environment, and they want to buy the units and buy exclusivity for Mexico. But most people around Tarpon Springs, around Michigan, are customers to Matheson. They just want the gas. The way we look at it is that our gas sales should cover our fixed costs and our variable costs, so that anything else is just development opportunities to the top line. That's what we'd like to do. Yeah? To answer your question?
I've got a number of questions, but I'll let you keep going.
Okay, well, it's up to you. Okay, so Maria Zach from the Strello Group is going to conclude.
Good afternoon. I just wanted to take a moment to go over some of the asks of the committee, and we certainly appreciate you inviting Magna Gas today to present. First, I wanted to talk about submerged plasma arc technology. I don't think anybody back 10, 20 years ago thought about putting this into the legislative bills that we passed down here, and so we haven't really seen definitions of it and definitions of a magnecular gas. So because those have never existed before, we now need to kind of take a different approach and different look. Had the Sunset Bill passed, I think maybe I would have approached this conversation a little differently, because now we're going to need the departments to go back and look at all the places in the statutes, everything under EPA, everything under Public Service Commission, et cetera, are going to have to go back and look through where they currently define any type of gas, define any type of process. And I'll give you an example real quick. It is illegal in Florida for waste treatment facilities to actually treat using the recycler on site, under certain classifications. So instead, they are trucking what is potentially hazardous material on the roads of Florida and taking it to another place to actually be handled. You would think that would actually be unsafe. So we would recommend that some of those rules that were in place for appropriate reasons in the past be re-examined. And our hope was to ask if the House and Senate Science and Technology Committees would pass a resolution urging the departments to examine the laws to allow for this technology and this gas. I think the opportunities as we go forward about defining and integrating the inputs and the outputs, because both are now newly differently treated under this new technological advancement, that's something that definitionally we're going to have to approach. I think with all the great work the Georgia Department of Economic Development's been doing, especially with the University of Georgia, and I'm sure we'll have many great, exciting advancements and announcements to come, we'll be able to even go a bit further in taking what the gas components are and how that can also change the world from an advancement in use with hydrogen fuels and the size of the molecules. We already know from some folks that the molecules are actually bigger than normal, so it really takes us into a whole different world of what can happen. Additionally, I think it would be helpful from a government perspective if we examine the cost savings to residents. I think as taxpayers, we all like to see that our tax dollars are used most efficiently and effectively. And one of them is in acetylene. Currently, the state of Georgia, on the procurement website, you look up and you look at the gases that are being purchased, and you see a large amount of acetylene being offered and purchased. So I think we want to look at opportunities there, as well as allowing for the gas deregulation model to work, of how would a gas like this work. And you're going to see a little map in a second that is going to make you rethink how we have looked at natural gas in the past. We did deregulation in '96 and have been living under a competitive environment, but this is going to kind of even disrupt that model a little bit as we go forward. So those are kind of some of the ideas. And then providing for access for direct piping. I believe it's DeKalb County. I saw Senator Miller just a little while ago, and I was commenting that, you know, I could go up to him and say, wow, DeKalb County's doing something great. And we remarked that, you know, it's not often we talk about what great things are coming out of DeKalb County this week, but I can tell you they have been state of the art when it comes to taking their methane, capturing it, and pumping it back into the system. So that's something that we would like to pursue on the sewage side, taking any of the plants here in town. I know the city of Atlanta is looking at converting all their taxi cabs over to just natural gas. So they could actually use the RM Clayton plant or any of the other plants and create their own natural gas and fuel their cars and their buses and their gas trucks, etc. Also wanted to talk about fast-tracking the waste fluid processing rules and easing compliance when it comes to something that is proven. So that's another area where I think we're going to have to look with DEP. As far as additional benefits to the taxpayers, I think that we're enjoying the luxury. Those who have natural gas vehicles actually are exempt from having to go through the emissions vehicle testing that the rest of us have to go through. And as far as the wisdom of the legislature, we want to thank you for the manufacturer's tax credit that you all passed. We know we're starting to see some of the taxes be implemented on the local side, so that would certainly make a decision-making process on our end of where we set up shop, how we do business. Businesses that might be interested in purchasing a machine, would they be exempt, wouldn't they? So that's kind of a situation based on the county that they're in. So that actually is having a ramification, but y'all were obviously very on the front end of seeing the wisdom in passing that. And last but not least, I wanted to mention about leveraging academic involvement. We have some of the greatest institutions in the world here, and we are so thrilled and grateful for the Center of Innovation for opening up the doors, for helping make that happen to where we're able to leverage and use their wisdom and talent pool. On the marketing side, the testing side, manufacturing and valuations, that is just a phenomenal opportunity for a company that has technology that is so diverse. And when you're sitting here with this on the front end, we can take all these spent fluids. On the back end, we have so many opportunities of ways that gas can be used. The door is wide open on both ends of what this could mean for Georgia and from the economic proposition that we have to offer. And I think it's a fascinating technology. And I wanted to show you this last slide on the future. And those of us who grew up in Florida and had an opportunity to go to Disney World often, y'all may remember the area for the future and people sitting back watching TV. And I was a small kid, and it really made an impact on me. Wow, we're going to have what later? So now looking at this is kind of not so far in the future now, where you could actually have a recycler at your own home collecting your own sewage and taking all your fats, oils, greases when you're cooking, especially if we love fried chicken in Georgia, and we go and we collect everything and we use it to power our own car, heat our home, and certainly watch TV. So when we talk about being off the grid, is it possible? It is possible, but it won't happen without the help of everybody coming together collectively to help solve some of the problems that stand in the place, such as government rules and regulations, to where I can tell you in the state of Florida, we sat in a meeting and we had probably 10 executives, and they were all scratching their head because they weren't sure whose department it ended up in and how to make the advancements necessary to even allow something as simple as testing. So we're just thrilled with the state of Georgia opening their arms and saying, you're a new business, you're growing, you're going to grow jobs, and they've been very welcoming, and we just can't say enough about the wonderful treatment that we've received. With that, Mr. Chairman, I will yield for questions.
Do we have questions? I'm sure there's some. Chair recognizes Senator Huffstetler.
When you talked about the 300 kilowatt unit and we're talking about the processing and how many homes and stuff, how many, put it in like gallons or something, how many gallons per hour or something with that process?
It all depends on the TSS, the total suspended solids, which is the amount of stuff in the water.
Mm-hmm.
And I believe it's 10,000 gallons an hour at 1% TSS.
Okay.
And by the way, this picture here is of my daughter with her required safety glasses on, being near the unit. You can see she's 6 years old. It's not a huge thing. That is a 300 kilowatt unit right there. Sorry. Yeah.
In terms of, we do have some more questions. Number 17.
Thank you, Mr. Chairman. Chairman Setzer alluded to this earlier in an earlier question, but what is really truly your biggest hurdle right now to really rolling this out? I mean, the economics that you rolled it out are very compelling, a 2/3 gross margin, people who want to get rid of feedstock. I mean, it seems very, very good. So what are your challenges right now to really rolling this out at a bigger scale?
I think, Representative, that some of the things that we've seen in some of the meetings has been the question about how EPA and DEP and EPD in each of the states are going to handle it. But also, I think that one of the things that we've seen is that there's a large amount of infrastructural costs, especially in the municipal waste side. Mm-hmm. So they have implemented that, and if they already have it and it's not being taxed, they are shy to go and get into something new.
They have a system that works. They're getting rid of their waste. They don't want to mess with it. And they look at EPA, it's too confusing. I don't want to, the typical just sort of inertia. Is that what I'm hearing?
Correct. Okay. Inertia is a large part of it.
Okay. And I would say access to markets. A lot of the markets that we're getting into, the industrial gas market, automotive market, power market, those are usually dominated by a group of players, and they move relatively slowly, which is nothing wrong with that. They want to do things right, but it's getting access to markets. We're a technology company. All we want is access to markets.
Is a lower cost of natural gas also? I mean, right now, I guess on the power side, you talk about the commingling, burning. Have you all tried to push hard at the power side? What's that?
We haven't even been pushing the sale of the natural gas just for gas heating of homes. That's just been a beautiful side item of receiving. But where we'd like to go is additionally if you could envision every Jiffy Lube, every Firestone, every Goodyear could suddenly become a natural gas station along with McDonald's and Burger King. So, they've got to get rid of their fogs and everybody's got to get rid of their waste. But there's no infrastructure from a government perspective at this time that allows for a smooth path for that.
One further question, Mr. Chairman. For safety, you talk about these small units and talking about putting them local. What's the safety, around the thing? Is it going what are the hazards, I guess, of having it on site?
Well, first of all, our units are CE marked, so they've gone through that as,
so you're CE certified.
Yeah, we're CE certified. But any industrial gas is dangerous. Some are more dangerous than others. The trickiest thing is if air gets into the unit, then you have magnetic gas, air, and a spark.
Yeah.
But all it does is just blow out the vent in the top and pepper your ceiling with all sorts of nasty things.
Fogs.
Yeah. I think it operates at around 30 psi, so I think it's considered to be low pressure.
Okay.
Yeah. One item, John, where's your property in Georgia? Above Dahlonega. In Suches. John is very keen to point out that our technology, because we convert so much liquid that we push down the drain into irrigation water, that would solve some of the drought issues that are in Georgia and lots of other states. And it's only going to get worse. I mean, they say that water is the new oil, right? It's just a matter of time. Our technology will make it usable.
Chair recognizes Senator Hofstadter.
But from before, I just
Okay. I've got a couple questions that are related. And these are going to come across as extremely simple, but I think for purposes of clarity, I want to help members kind of get their mind around it. At the density you described, 10,000 gallons per hour for 300 kW units, not unrealistic. That is an extremely high volume. You think about it, the tankers that are running down the interstate to your racetrack stations and to your BP, those are 8,000 to 9,000 gallon tankers. So you're talking about one of those in an hour, pumping through at a 1%. Is that's the quantity of gas that we could get our mind around?
No, sorry. Just to clarify, we were talking sterilization mode. How much sewage we can process an hour?
Okay.
At 1% TSS, which is the percentage of stuff in the water, we can sterilize 10,000 gallons an hour.
Okay.
For every, like I said, I like to keep things very simple. And I've studied all our units and I've plotted it, and it's exactly linear. For every 100 kilowatts of power you put in the unit, using ethylene glycol, which is not the best feedstock but is the cheapest feedstock we can find, you always produce 1,000 cubic feet of gas an hour. So 100 kilowatts is 1,000. So if you're 300 kilowatts, 3,000 cubic feet of hour.
Okay. And how much, if you're in gasification mode, how much input do you have to put into the system to get that?
Not a lot. It only consumes around 10 gallons of fogs an hour, which, if you're trying to get rid of liquid, it's not a lot. But we look at it as fuel. Why burn through more fuel than necessary? It'll only take 10 gallons an hour at 300 kilowatts. So it's roughly, for every 100 kilowatts, it's about 3.5 gallons.
So, in terms of a flow, sort of an ecosystem, the way everything ties together, if you will, is there a model for having proprietors buy your systems, set them up somewhere, and then have trucks go around and collect feedstock from different people who want to give up feedstock, bring them back to the unit, produce gas in a localized way? Is that?
Yeah. I mean, Maria mentioned Jiffy Lube, and that's a great example. Jiffy Lube already have the liquids. They already have to truck them across wherever to go to the recycling position, the recycling location, which is expensive and dangerous. You need DOT placarded trucks, et cetera, et cetera. We can literally drop a unit there, start producing gas, and if you have a natural gas vehicle, you can just pull up to Jiffy Lube, say, okay, change my oil, fill me up, and you go.
Okay.
And Mr. Chairman, if I may also add, for the farming community, one of the issues that we've been asked about frequently is about the amount, the volume. Some of the pig manures and farming community folks have had issues where they don't produce enough volume, so what do? For the poultry industry and chicken macerations, obviously, we could have a facility set up and others can all pull from it within the rural community, so that way it's one-stop shopping if they don't have the head number of hogs at a specific site.
So to follow my line of questioning, if you're able to take 10 gallons an hour with a 300 kW unit through the gasification process, how much Magna gas is that going to produce? And I don't think in terms of cubic feet. Give me a cubic foot number, then give me a market value of that, so I can get my mind around what.
Well, okay. I see where you're going. Okay. A 300 kilowatt unit consuming 10 gallons of the fogs will produce 3,000 cubic feet of gas. And the market value for that gas today is between 15 and 10 cents a cubic foot.
Okay. At 10 to 15 cents per cubic foot. Now you said it cost you 2 cents to produce it. Is that?
If we get the fogs for free, yes.
Okay.
We have three costs: the liquid, the electricity, and the electrodes. Our top expense today is the feedstock. We pay $435,000 a year if we operate at 85% capacity, just to purchase the feedstock.
Okay. So in essence, what the machine does, at 10 to 15 cents a cubic foot, at 3,000 cubic feet per hour, it's about a $300 to $450 an hour machine. It's producing $300 to $400 an hour of product, and then you work that into your business model of paying down the cost to buy the unit and the economics of working. And I'm just trying to think of that. So in essence, if you've got a proprietor out there that wants to buy one of these things in a lowboy truck and drive around with it, or if he wants to set it in a single site and then go bring feedstock in,
yep.
If he's running 20 hours a day, which is a standard, round the clock planning number with maintenance and all, he's got a $300 to $400 an hour revenue generator in terms of selling his gas.
Yep.
Okay. Chair recognizes Senator Loudermilk. Is that you? Is that Representative Braddock?
Oh, thank you, Mr. Chair. So in the numbers that you gave us, does that include your transport cost to bring those fuels to the facility to process? Or is that not in that equation?
That assumes no fog, just zero cost for fogs, no transport, nothing.
Okay, like it's there and you're just processing it. Okay.
For example, if we drop the unit in Michigan, in Flint, all they have to do is truck it over 10 feet and we're there.
Okay. And right now, your application is commercial for large facilities like the military, General Motors. Are you currently able or ready to go into like Jiffy Lubes and do that level of commercialization? And then your next phase will be the smaller units that can be used in the home. But where are you on the mid-size type companies that want to convert their own waste products to something sellable?
Well, we could very easily do the Jiffy Lube model today.
Okay.
I wouldn't want to be the one who's going through the regulational requirements, the setup requirements, the pumps, all that. I would
But
just
you are
think
the
that-
one, aren't you? Isn't that kind of what you're doing?
Well, today we make the gas and we
Mhm.
package it in bottles and we sell it, or we place units on site for large customers.
Okay.
The way I see it is that we can piggyback off of the natural gas initiative for automobiles, which is basically doing the same thing, and we can.
So once you get through this regulatory environment, then that's really the only thing impeding you from going into Jiffy Lubes right now? Is that where we're at with this?
Yep.
Okay. Yeah. Okay. Thanks.
Thank you, Mr. Chairman. This is just kind of a curiosity question. How many people does it take to run the unit?
According to OSHA, it requires 2 people. But you flip the switch, get on a conference call, just monitor the panel, and you're done. The requirements are in this unit here. Oops, where is that? In this unit here, there are 2 electrodes. They're about half the size of my daughter. The unit, what's special about our equipment is that the controller controls the gap between the electrodes to maximize the voltage. The higher the voltage, the more liquid you're affecting, and that's why we're inherently better than other systems, because most of the other plasma arc systems for solid, you're basically heating up and burning air. We don't touch air. Every single watt touches the liquid. Those electrodes consume down, and over the course of 8 hours, they're consumed and they have to be changed. Engineering-wise, if you look on the top there, very simple stuff. We have lots of bolts around there to over-engineer it. We could easily put a hydraulic clamp there to speed it up from a half an hour to 20 minutes. But that, once it's on and you're connected to the feedstock, that's all you do. Yeah, John was saying there is, of course, an automatic shutoff. So if you run out of feedstock, it shuts off. If the electrodes short out, it shuts off. There are several shutoffs. Like I said, to get a CE mark, I can't begin to tell you the amount of work and proof that it required in testing to show that it was safe. But we currently need 2. Now, if you have 2 people operating, you could operate 4, 6, 8, 10. As long as you have 2 people, that's all it takes.
What's the largest unit you've got? 500 kW?
Yeah. Yeah.
Turn everything else.
No, thank you.
Whichever one you want. Well, we could bring the 500. We could bring the one on the trailer that has the remote control and diagnostics as well.
Okay, any further questions? Chair recognizes Senator Hofstadter.
What problems have you had with units, or maybe the better question would be what kind of lifespan do you have on these units, electrodes, that kind of thing?
Well, the electrodes in the 300 kilowatt unit is 8 hours. And all we do is the anode the cathode consumes faster than the anode. So all we do is, and they're the same size, we take them off, we move this down here and replace the top one. That's it. Problems, if there's a very thick fogs, you will get a buildup of carbony. It's almost like a soot inside, but it's not. It's just a carbon stuck together. Mm-hmm. So when we take out the electrodes, we sometimes have to clean out that carbon.
So you're changing out the electrodes about every 8 hours, you
Yes.
said, and
Yeah.
and what's the cost of those?
If you operate at 85% capacity, I believe it's less than 100,000. It's about 70,000. I don't remember exactly, but that's the third. The first is feedstock, second is electricity, and then it's the electrodes.
Okay, I missed something there. You said 100,000 per
Yeah.
year.
Yeah,
Per
yeah.
year.
Sorry.
Okay, based on continuous operation, or
Yes.
okay.
Yeah.
Senator, you did get to my last question, which was the energy costs, energy inputs. I was going to ask you about, obviously, to have a gas that can power a mobile vehicle, you can't just plug yourself into a nuclear power plant or a coal fire plant and drive around. There's value to being mobile. It's part of what gas does for you. What's the gas? What's the power input into the system to generate the gas that we're talking about? Could you give us a percentage? We spoke about that a little bit before the committee hearing. Frequently you would think about more total energy coming into the system that's going to be yielded, that's going to be converted to gas and come out of it. What is that ratio, and what is the cost of that?
The test that we've done in Italy, because there they get favorable tariffs for green energy they put into the grid. For every 100 kilowatts of power that you put into the unit, you produce the gas and you produce the heat. Not capturing the heat, if you just burn the gas, you get 50 kilowatts of power back.
Okay. And that's not with any waste heat recovery. That's just straight into the gas. Okay.
Right.
And right now, you're in the research process to try to recover some of the waste heat and use that kind of cogeneration model, or.
That is something we have not focused on, but with General Motors, that's something we're going to be looking at. That's one of their objectives is forklift, electricity production, and heating cooling.
Okay.
Now, you talked about driving around with a magnet gas unit on the back of your car. Yeah, that's problematic.
Yeah.
But we think that a model where you have a municipality that has, at a first stage, non-critical vehicles such as sanitation, pickup trucks, parks, etc. If you have them obviously going around that municipality, you have the solid waste facility, you have the liquid waste facility. Every time they come by, they just fill up the tank, and they keep on driving. So that would be a great start for Magna Gas, because obviously you have a limited range. It's not a critical thing, and it's a great way to introduce it to the automotive market. And I suspect that that's what General Motors is angling towards.
Once again, your cost per cubic, or your retail price per cubic foot that you would get from customers is somewhere in the 10 to 15 cent per cubic foot range. What's the cost? What is natural gas getting these days per cubic foot? I know we think about it in different quantities. Do you know?
Mr. Chairman, when I looked at the PSC website the other day, it was at $1 roughly.
$1 a cubic
$1
foot.
therm.
Therm.
$1 therm.
This is the problem. We're talking in therms, and we've never done the calculation in therms. But propane, which is one of the most widely used bottle gases, and it's used for transportation as well, is 6 to 10 cents a cubic foot retail.
And Mr. Chairman, one other thought on that. With the way the Public Service Commission now regulates natural gas in Georgia, you have interruptible customers who are your manufacturers, and at high peak demand, they're shut off. So this is a nice, easy solution. One of the businesses we talked to in Savannah, located near the port, started thinking about the synergy of, you could take the business who needs the gas when they're interrupted, the port that needs to fuel forklifts and could get rid of a lot of their sludge and sewage, and then you also have the municipality who's getting rid of sewage. So you kind of could marry up and have a joint process between the three that could really turn out quite nice.
Any further questions? Well, I've got 20 minutes after 4. We've gone for about an hour and 15 minutes. Any last wrap-up points for the committee? Again, we've been really appreciative of you coming out. It's been a great presentation. Any last things you'd like to leave with the committee?
Mr. Chairman, if I may, I'd like to recognize Ken Nemeth with the Southern States Energy Board, who is here today. Ken has been very invaluable to us in this quest of building this new technology company, and for his work with Congress, it's important and invaluable as y'all look at your state legislative laws and our work with the National Conference of State Legislatures, as well as we've just been requested to participate with ALEC possibly this summer. We also want to look at CSG, but as we go forward with Ken's work and the work of the members of Georgia from the Southern States Energy Board, including Representative Geisinger, who is here today as one of the appointees, we desperately are in need of help of getting government out of the way and helping move this technology forward. So I would just respectfully request that as you move forward and you're hit with different opportunities of where this technology, either in the farming community, ag, all the way to natural gas, to everything from aviation fuels, this can totally have an impact in what you're doing. And we just want to make ourselves available to you both, Chairman, and to your committees in any way possible to help in navigating that new territory. Thank you so much for having us.
Thank you. One last note for folks, as we had announced earlier today, because of the nature of this, there's questions that come out of this, and sometimes just sort of an informal banter really leads to folks getting their mind around this better. We are going to do a reception tonight, sponsored by the Stroller Group. It's going to be an official committee function, both for the House Science and Technology Committee and the Senate Science and Technology Committee. It's going to be Capitol Grill, 5:30 to 6:30. just a very simple reception, not dinner. But thought it'd be appropriate to kind of have some time after this as we kind of process this to have a simple reception. Appreciate you hosting that. And again, it's going to be an official committee function for both House and Senate. So if anyone wants to join us, feel free to do that. Linger after, ask some questions. But Senator Loudermilk has one question.
I was just going to remind the chairman to mention the reception event that was going on tonight. And we thank you very much for being here. This is exciting. I know we spent a lot of time talking about it. This is revolutionary type ideas, and I think I'm very excited about it. So we appreciate your time.
Adjourned.